Good afternoon, everyone, and thank you for joining us. My name is Dan, and on behalf of Team 4, I'm pleased to walk you through our proposed integration of an open source security and information event management system, or SIEM, into the Institute for Computational and Data Sciences.
WASA is an open source security platform. It is free, with no vendor lock-in, and has an active community of developers improving it every day. With WASA, you will have threat detection, security monitoring, incident response, regulatory compliance, and all in one platform. Go to wasa.com to get more information.
The cybersecurity team at ICDS requires a new solution for a more cost-effective SIEM. The issue results from their original SIEM, Oracle Splunk, requiring paid licenses to continue using the service. Their cybersecurity team has directly handed over responsibility for the research and installation of the SIEM software to our team. The purpose of this initiative is straightforward yet vital. We must replace the costly Splunk add-on, now straining our budget, with a modern platform that provides equal or better visibility at a fraction of the price. Our team will explain why WASA meets that goal, how a modular integration strategy eliminates risk, and what measurable benefits you can expect once the system is in full production. We will touch on business drivers, architectural design, information flows, and the concrete next steps that will take us from pilot to campus-wide deployment. By the end of the presentation, you should have a clear sense of both the technical roadmap and the financial upside of this transition.
Hello, class. My name is Charlotte, and I will be presenting our business drivers, strategic scope and risks, and our current environment assessment. To set the stage, let's review the key forces behind the project. First and most obvious is cost. Our Splunk license renewal was projected to exceed $350,000 over the next cycle, a figure that does not align with the ICDS's mandate to operate, learn, and reinvent savings in research. Secondly, the research community requires deeper threat detection as workloads grow on our higher performance clusters. The current stack delivers logs, yet it struggles to correlate events at scale. Third, analysts are spending hours each week on manual triage, so automating incident response has become a productivity imperative. And fourth, compliance pressures from HIPAA and GDPR continue to mount, demanding constant retention, encryption, and audit trials. A successful solution must therefore lower speed, sharpen detection, shorten response, and simplify audits, all while preserving the flexibility to grow with demand. Throughout the presentation, you will see how every architectural choice traces directly back to one or more of these four goals. Our scope covers the full lifecycle of SIEM integration, starting with stakeholder alignment and risk assessment, moving through tool selection and pilot, and accumulating in phase production and rollout. Major stakeholders include the SOC, IT operations, compliance officers, and the HP research community. The primary risks are downtime during cutover, potential data loss while we migrate historical logs, and schedule creep if integration points prove more complex than planned. To mitigate downtime, we have architected a parallel integration path that allows Splunk and WASA to run side by side until confidence thresholds are met. For data protection, nightly snapshots of the existing log indices will be stored in Azure before any switch is thrown. And to keep the timeline realistic, we have divided delivery into clearly bounded sprints, each with exit criteria and stakeholder sign-off. By addressing these challenges head-on, we ensure that the integration remains a value add rather than a disruption. Let me paint a picture of where we stand today. ICDS operates a hybrid environment, an on-premise high-performance computing cluster managed by Slurm, a growing footprint in Azure for elastic workloads, and SaaS platforms such as Microsoft 365 and ServiceNow for collaboration and ticketing. Security telemetry arrives from dozens of heterogeneous agents, and while Splunk ingests this data, the pipeline relies on custom scripts that have become difficult to maintain. Identity remains split between on-prem Active Directory and Azure AD, leading to duplicated policies and occasionally blind spots. In short, our environment is rich in capability, but fragmented in governance. Any new SIEM must unify visibility across these domains without forcing us into a single vendor lock-in or a wholesale redesign of working systems.
Hi everyone, I'm Vincent. I'll be going over the integration strategy, conceptual architecture, service-oriented components, and our key standards and technologies. Our proposed strategy is event-driven and fully modular. At the edge, we normalize every log or event into a common JSON or CEF format. Those messages enter secure ingestion gateways and perform lightweight validation and attach metadata such as source, sensitivity level, and retention tags. From there, the events travel across either Apache Kafka on-prem or Azure Service Bus in the cloud, depending on the origin. Normalization and routing are handled by Apache Camel, so by the time the data reaches the Waza core, it is a schema consistent and ready for rule evaluation. Because each layer, sources, gateways, streaming, SIEM core, and automation operates behind a well-defined interface, we gain two immediate benefits. First, we can scale any tier independently, and second, replacing or upgrading a tool in one layer will not ripple outward and break the rest of the stack. Architecture, therefore, meets our goals for flexibility and low operational overhead. The diagram you see is a conceptual future state architecture. Layer 1 is the log and event sources, Azure VMs, Slurm models, Microsoft 365, ServiceNow, and Red Hat servers. Layer 2 is the secure ingestion gateway, where syslog, TLS, REST endpoints, and Waza agents perform initial checks. Layer 3 is streaming and transformation, Kafka for campus data, Service Bus for cloud data, all normalized by Camel. Layer 4 is the Waza core cluster, 2 managers and 3 indexers running in active to active, correlate, alert, and store. Layer 5, the topmost, is automation and reporting, where ServiceNow creates tickets, Power Automate launches playbooks, and dashboards update in real time. Each layer publishes only vetted data to the next, keeping the security boundaries clear and performance turnable. Drilling deeper, each major capability is abstracted into its own reusable service. Log ingestion enforces schema compliance. Threat detection executes anomaly and rule-based analytics. Incident response integrates with ServiceNow to open, assign, and track tickets. Compliance export packages signed log bundles for auditors. Workflow automation strings these services together, allowing us to add or adjust playbooks without touching the detection logic beneath. We can introduce a new analytics engine or different ticketing platform by swapping endpoints, not rewriting code. Standards provide the connective tissue. All network traffic uses TLS 1.3 end-to-end, ensuring encryption in transit. Payloads are expressed in JSON or syslog with common event format extension for security context. Metadata adheres to open cybersecurity schema framework, so analysts see uniform field names across sources. For identity, we rely on SAML and OAuth 2, giving us single sign-on and token-based API access. Process flows are documented in BPM, and orchestrated by Microsoft Logic Apps or Power Automate, which simplifies audit and change management. Finally, we align every control to external regulations: HIPAA for research involving health data, GDPR for any EU participants, and NIST 800-61 for incident response discipline.
Hello everyone, I'm Kevin, and I will be discussing metadata, business process flows, performance and capacity planning, and security and compliance controls. A strong SIEM is only as good as its metadata. We maintain canonical fields such as source IP, alert ID, and incident ID so that every downstream consumer speaks the same language. For example, when WASA raises alert ID A123, ServiceNow records the same identifier as the primary key for the ticket, and our reporting dashboard references it identically. This one-to-one mapping prevents duplicate reports and supports full lineage from raw log to compliance report. All mapping live in an enterprise repository, giving developers a single source of truth and auditors a clear lineage trail. Business process flows. Operationally, the process begins the moment a monitored system emits a log. Within milliseconds, the ingestion gateway tags the record and queues it. Streaming transports the event to WASA, which applies correlation rules and anomaly detection. If the event is benign, it is simply indexed. If it meets a rule threshold, WASA flags it as an alert, publishes a message to ServiceNow, and a ticket is created instantly. Power Automate then consults the playbook appropriate for the alert category. For a critical credential stuffing attempt, the playbook can disable the account in Azure AD while simultaneously notifying the SOC. All associated artifacts, the original log, the alert, the ticket, and the automated response, are stamped with common IDs and time synced. This closed loop completes in under 5 minutes for high severity events, meeting our MTDD target and freeing analysts to focus on investigation rather than data wrangling. Performance and capacity planning. Scalability has been validated through load testing. Our design comfortably sustains 75,000 events per second, well above current peaks, with headroom for seasonal surges. Round-trip latency from event arrival to indexed record averages under 100 milliseconds. The WASA manager run in a 2-node active-active pair across separate racks. If one node fails, the other takes over with no loss of state, satisfying the 99.9% availability SLA. Kafka brokers are containerized and deployable on additional bare metal servers, allowing horizontal growth without downtime. Storage uses a mirrored NAS for recent indices and geo-redundant Azure Blob for long-term retention. Together, these choices assure both performance and resilience. Security and compliance controls. Security is layered and explicit. Authentication relies on Azure AD tokens and optional multi-factor prompts via Microsoft Authenticator. Role-based access controls define what analysts, researchers, or IT support can see or change inside WASA. Every administrative action is logged, hashed, and pushed back into the SIEM for its own oversight, an approach sometimes called self-monitoring security. Data at rest is encrypted with AES-256, while network traffic is encrypted with TLS 1.3. These measures align with HIPAA, GDPR, and NIST 800-63 guidelines, ensuring that regulatory checklists are met out of the box rather than bolted on later.
So during the pilot, we ingested 27,000 events. The dashboard shows 308 successful authentications, but tellingly 0 failures. That gap indicates our rules for failed logins need tuning so brute force attempts aren't slipping through unnoticed. We also discovered that about 12% of agents were idle, probably due to configuration drift, which highlights the need for heartbeat monitoring. Finally, a CIS Linux benchmark produced only a 49% pass rate, revealing compliance gaps that predate our SIEM work yet must now be addressed. The good news is that WASA's modular design lets us resolve each of these issues by adding rules or scripts rather than redesigning the platform. So, based on those findings, we recommend 4 concrete actions. First, within 30 days, we need to tune detection thresholds for authentication failures and privilege escalation. By day 60, deploy heartbeat monitoring so silent agents raise alerts after a short grace period. By day 90, integrate automated remediation scripts that harden CIS controls, closing SSH where unnecessary, enforcing file permissions, and so forth. And in phase 2, add user and entity behavior analytics plus full SOAR playbooks to reduce mean time to respond even further. Each milestone is incremental, measurable, and designed to deliver value without expanding the staffing footprint. In conclusion, migrating to WASA gives ICDS a future-proof SIEM that aligns with our budget realities, our performance targets, and our regulatory obligations. The modular architecture we have outlined means the system will evolve gracefully as workloads grow and new compliance mandates emerge. Success hinges on 3 factors: ongoing rule tuning so that the SIEM stays sharp, continuous automation to keep analysts focused on high-value work, and centralized governance to ensure consistency across our hybrid estate. With your approval, stakeholders, we are ready to move from pilot to full production this summer. I appreciate your time and attention, and I welcome any questions you have. Thank you.